These days, with an ever-increasing demand for comfort and high-tech industrial needs, most modern buildings are air-conditioned. Modern air conditioning systems provide a controlled indoor environment. Most systems provide adequate temperature control. For more sophisticated and industrial applications, the air conditioning systems are designed to control air quality and humidity. Let us see how an air conditioning system maintains a cool and comfortable interior environment. In most central air conditioning systems, the room air is recirculated to the air handling unit, or AHU in short, via air duct. The room air is drawn into the AHU by the suction force produced by the fan inside the AHU. In the larger system, a separate return air fan may be installed in the return air duct to draw the air back to the AHU, where some outside air is introduced. The mixture of return and outside air is passed through a filter before passing across the cooling coil. Inside the AHU, the mixed air around 25 degrees Celsius passes through the cooling coil. After passing through the cooling coil, the air is now cooled down to approximately 15 degrees Celsius. The cooling coil is made of copper tubes and aluminum fins. Chilled water at around 6 degrees Celsius is continuously supplied to the cooling coil to absorb heat from the warmer air. After being cooled, the air is then delivered by the fan back to the room via the supplied air duct. The cycle of air circulation repeats. The variable air volume system, or VAV in short, can be found in multi-zone applications like offices and shopping complexes. In this system, the supply air temperature is kept constant while airflow volume varies with the room temperature. It is most suitable for multi-zone applications because it is an energy-efficient system for dealing with zones that have different cooling loads. In this case, as a result of the additional heat gain in this room, the temperature will rise. Signals are passed to the VAV terminal box, which is used to regulate the supply airflow. The supply air from the AHU at a common temperature is supplied to rooms having different cooling loads. The information that is passed on to the VAV terminal box signals that the room temperature is too high and it needs more cool air to be supplied to the room. The damper inside the VAV terminal box is therefore activated to rotate to provide a larger opening position to increase the supply air volume flow rate. As a result of more supply air, the temperature of the room is returned to its set point temperature. If the temperature of the room drops, the damper plate will rotate to close, thereby reducing the supply air volume flow rate.